Hello everyone, and welcome to this video where we'll be discussing like terms and distribution, two very important properties to algebra. So let's get started. Okay, I'll admit it, we're doing a little bit more than just like terms and distribution. Here we're doing combining things together to simplify expressions. So we're using some properties here in order to do all of that. Let's take a look at what I mean. As far as vocab goes here, we're looking at two terms that are likely fairly new here. The first is the distributive property, which is the process of, in business, it's the idea that you distribute whatever you have to whoever you're selling it to. You put everything in trucks, and those trucks drive out to the stores. The idea of distribution in math is the idea of taking something and distributing it out to parentheses. So if you have something that you're multiplying into parentheses, then you want to multiply it to everything in the parentheses. The other thing here is like terms, which is the process of combining terms, combining parts of a problem that have the same exact variable written on them. Now I'm going to start here with like terms. This first problem, you want things that have x's on them. So we have 7x's and take away 3x's, which leaves us with a final value of 4x's. Now, I would ordinarily want to try to do 4 plus 12. However, I can't because the 4x and the 12y are different letters. So when it says to evaluate, we're going to get as close as we can to a final answer, but I can't get any closer to a final answer than 4x plus 12y. It's simply a matter of I don't know how much x is worth, and I don't know how much y is worth. For our second example, it's curious because there are multiple places that have n on them. However, one of them is different than the others. This minus 8n at the end here does not have the same thing on it as the first n squareds. So I will combine those together, the 12n squared and the minus 5n squared. They'll make 7n squared. But those must be kept separate from the minus 8n. Why does the minus 8n have to be different? Well, because the 7n squared is what n squared is worth times 7. In the order of operations, this squared would have to go before we dealt with the 7 or the 8. So I can't combine the 7 or the 8 until I know what n squared is or what n is, and those are likely different things. In the case of the plus 6 and plus 2, we'll just make those a plus 8, and then we're done. I can't combine anything else here. Let's move on to the next example. On this slide, I want to show how the distributive property can actually be really helpful in terms of raw calculation. Say you want to do 8 times 13, and you're like, I don't know how much that's worth. One way you might approach it is you might say it's 8 times 10 plus 3. When you approach a problem like this and you say, well, 10 eighths is 80 and the other 3 eighths is 24, and I can just put those together, you're actually using distribution there. The idea is to do part of the problem and then another part of the problem and take those parts and put them back together at the end. From a visual perspective, we're just taking 8 times 10 and 8 times 3. And then we take those 80 and 24 numbers, and we'll add them together to make a total of 104. For our second example, in letter B, I'm going to be multiplying a negative 3 into 3 different things, because there are 3 terms here. Each of them is getting separated by an addition or a minus. You'll notice I draw these arrows. Those are a visual cue to help me remember what I'm multiplying in and what I'm multiplying it to. So I have negative 3 times x squared. I have minus 12x, and I have a double negative with the negative 3 times 7 that's being subtracted. That double negative turns into 21. At this point, because of like terms, where I have x squared and then just x and then just 21, I am done combining things, and this is my final answer when I'm trying to evaluate for letter B. Our final example puts these two major concepts of like terms and distribution and puts them together into one big problem. And there's something you should notice right away. I'm multiplying by a negative 9, and that goes into the parentheses, and has a minus 9a and again a double negative of negative 9 times negative 5 for a positive 45. Since the parentheses stop, so did my distribution. However, there's another parentheses for the 2 multiplied into the 6 and the minus 7a. So after this first step, I've distributed twice into the parentheses, one for the negative a and one for 2. And then I need to combine some like terms together to make my final result. Here I see two values of a that go together, a minus 9a and a minus 14a, which will make a total of negative 23a. I also see a plus 45 and plus 12, and neither of those have a variable on them, so those also go together to make a total of 57. My final result, because of distribution and like terms, is negative 23a plus 57. Welcome to the synopsis of the video. We've been discussing simplifying expressions with distribution and like terms, but I gotta give you a quick note here. Notice that we have 2 times these parentheses. If you ever get something with adding, you can't use distribution. Distribution only works if you're multiplying into parentheses and distributing a multiplied value. It does not work with only adding. Whereas with like terms, you want to use adding and subtracting to combine the things that have the same expressions on them. So these both have x squared on them, so I'll put them together. These both have a y on them, so I put them together. I hope this all makes sense, and I hope you've enjoyed this video. I hope you take care of yourselves. I'll see you in the next one. Have a good day. Bye!